So we have a motor that's lifting a block. We're given the mass of the block. We're given the velocity, it's a constant velocity. We're given the current that is passing through the motor and the potential difference across the motor. And we're trying to work out efficiency. Now efficiency has a couple of equations. It's either equal to the useful output power divided by the total input power, or it's equal to the useful output energy divided by the total input energy. So both of those things, options, are useful output divided by total input, and the ratios can either be of energies or they could be of powers. So in this case, I think we're going to be using power. Because we have current and voltage, so we can consider the equation P is equal to IV. We're not given any kind of time to convert this into a energy, so it's most likely going to be power that we're using in this question. The input power in this case would be the electrical energy, so this is Pn. And for the output power, so the useful output power, well, there's a few different types of energies that we have here. We have a constant velocity, so there is kinetic energy involved. The block is rising, so it's gaining potential energy, gravitational potential energy. And then there would be wasted energy as well, so things like heat in the motor because of friction, or energy transferred to air molecules because of air resistance as the block rises. So those would be the wasted energies. The useful output energy would be gravitational potential energy. It wouldn't be kinetic. And the reason it wouldn't be kinetic is because the velocity is not changing. Velocity is not increasing, it's staying constant. So we're not gaining any kinetic energy. We are gaining gravitational potential energy, and we can assume that that is the purpose of this motor or this setup. It's to raise that mass. So that is our useful energy gain. So then let's write down the equation for efficiency. So remember, it's the useful power output over the total power input. We have the power input, but how can we get the useful power output? So if we think about the equation for gravitational potential energy, E is equal to mgh. We have a mass, we don't have a height, but if we divide this by time, so power is energy over time, so if we divide the energy by time, and we split this up into two parts, so mg multiplied by h over t, distance over time, that's height gained divided by time, that quantity there would be the velocity. So h over t is the velocity. So I'll put that up here. V is equal to h over t, and that is 0.4. So then the useful power output would be mgh over t, so that would be 0.05 multiplied by 9.81 multiplied by the velocity, which was 0.4, and this will give us 0.1962. And the unit would be watts. And for the input power, the total input power, current times voltage, 0.085 multiplied by 3, and that gives us 0.255 watts. And then we can put both of those things into our efficiency equation. Efficiency is then going to be 0.1962, all divided by 0.255. We work that out, and that gives us 0.769. And then we can times that by 100 to convert it to a percentage, and we get 76.9%.